Hey students, good morning. The next topic we are going to see is about viscosity. So what is a viscosity is most of the fluids offer resistance towards the motion. So whenever any fluid is moving, it offers some resistance. The frictional force acts at the contact of the surface when the fluid moves relative to the solid or when two fluids move relative to each other. So when two fluids are moving relative to each other like this, then this contact, there is a frictional force. Same way, one fluid is moving near the solid, between this there is a frictional force. Okay, this resistance to the fluid motion is similar to the friction produced when the solid moves on the surface. Okay, so when the solid is made to move on any surface, there is a friction. So that friction and this resistance are same, and that internal friction existing between the layers is called as viscosity. Okay, so that friction which is existing inside the layer, that is called as viscosity. Viscosity is defined as a property of the fluid to oppose the relative motion between its layer. Okay, so between any two or three layers, between this there is a opposition of the movement. Okay, that is said to be viscosity. Clear what is viscosity is? Okay, cause of viscosity: consider a liquid which is flowing through a horizontal pipe with the two neighboring layers. So consider any fluid which is flowing in the horizontal pipe like this. The upper end tends to accelerate the lower layer, and in turn the lower layer tends to retard the upper layer. Okay, so what happens here is the upper layer will accelerate the lower layer so that the lower layer can move fast. Okay, and the lower layer, what happens in turn, retard the upper layer. Retard is, it makes it to be the constant one. Okay, as a result, backward tangential force is set up. Okay, and this leads to the viscous behavior, and there is a viscosity. Okay, so this is a container, and over this container we have this to be the liquid flow, top and the bottom layers, and here we have the viscosity, and let us consider with the 2 points p1 p2 and length to be L in this. Okay, and the coefficient of viscosity, what is meant by coefficient of viscosity is, consider a liquid which is flowing in the horizontal layer, fixed layer, and it has the velocities. Consider it has the two layers A and B. V and V plus dV be the velocities. Then the distances are x and x plus dx. Okay, having this, so this is layer A and this is layer B. So this has a velocity v, this is v plus dx. Okay, this is x and this is dx. Clear? So for this, if you find the coefficient of viscosity, the force of viscosity between the two layer is given by, and the force is proportional to, one is area and the next is velocity gradient. Okay, so the F is proportional to area first, next it is proportional to velocity gradient dv by dx. Okay, and so combining this both, it can be written as F proportional to a into dv divided by dx. Okay, now to remove this proportionality to equal to, will be always introducing a constant, is it not? And the constant which you are introducing here is minus eta. Okay, where eta is called as a constant of proportionality, and that eta is only said to be the coefficient of viscosity. Okay, so eta is called as a coefficient of viscosity. Here we have the minus sign, is it not? And minus sign says that the force and the velocity, they are in the opposite direction. Okay, it opposes the relative motion, and the dimension formula is m l power minus 1 t power minus 1. Okay, clear?